in general, the mindset is more important than the tooling. But there are lots of tools which help integrating the customer to our projects. I think it's also possible without it if you have the mindset. If you want to have this knowledge shift, you don't see writing code as your primary goal, but you see it also as your goal to enable others to understand what you're doing, how you're doing it, and enable them to develop it and maintain it by themselves.
You are listening to the Future Proof Operations podcast. The manufacturing sector is evolving, and the work that happens on the front line is the key to driving future readiness. On each episode, we bring you conversations with global leaders in industrial companies. Our goal is to discuss trends, stories, and people in digital manufacturing, and offer the latest insight into solutions. Subscribe and be sure to check out our website for more resources at operationsone.com. I'm your podcast host, Benjamin Brockman. This episode is brought to you by Operations One. Operations One is the leading platform to bring operations to a new level of excellence. By supporting frontline operations from planning to execution to analytics, companies benefit from an empowered workforce, increased operational excellence, and future-proof operations. Visit operationsone.com for more information. Hi Manuel, welcome to the Future Proof Operations podcast.
Benjamin, hi, and thank you for your invitation.
Great to have you on the show. Manuel, could you give me a 60 seconds overview of who you are and what you are doing?
Yes, sure. My name is Manuel. I'm 36 years old and live in Germany near Karlsruhe. I made the PhD in mechanical engineering because I like industrial manufacturing processes a lot. However, I also love software-based solutions, simulations, and data analytics stuff. I like them because they allow to make database decisions. And at ITK, I was able to union both aspects, the mechanical engineering part in our smart factory projects and my affinity to simulation and database decision making. And this is why I work since 6 years or for 6 years now at ITK Engineering.
You're working at ITK. Could you share with us a little bit more background about ITK and its mission?
ITK is a reliable development partner for a broad range of systems. At ITK, we bring our best engineers together to make different systems intelligent. We work in different domains like automotive, rail, health, or industry projects. And the systems we work on, they have a broad range of variety where we try to improve them. ITK has 1,400 employees. Most of them are engineers. So we have a high focus on technology topics.
You mentioned the smart factory already, and in our preparation call, we talked about Industry 4.0 for some minutes. You have been studying mechanical engineering. How did you come from mechanical engineering then to the smart factory and the field of Industry 4.0?
I think this is a personal question for me, so I need to go a little bit back in time to answer it. It was around 2011, 12 years ago. It doesn't feel that long. Time flies, right? Yeah. So around 2011, I was doing my master's thesis in a topic that included the optimization of an electrical coil in regards to magnetic field strength and homogeneity. And I was using different programming and simulation tools to solve this issue of optimizing the magnetic field of this coil. And somehow I simply liked to integrate the different aspects you could do with simulation, with data, and thinking of how can the coil later be manufactured, like the real problems in engineering. How could you manufacture something in an efficient way? And I liked all of that very much, that I said, okay, I want to work as a PhD student at the Institute for Production Science in Karlsruhe at the KIT. And this was the time when e-mobility was rising and the term Industry 4.0 was just rising. And if you work at a university, you get in touch with the current topics or the buzzwords which always are out there. And for my time, it was Industry 4.0 and this e-mobility. This was when I first came into contact with Industry 4.0. And I liked the idea very much to collect data of different sources, of connecting them and have manufacturing processes which are more efficient than the ones you had several years ago.
Interesting. And of course, a great topic for this episode, because myself personally, I'm very much into the digitalization of the factory as well, into the topic of Industry 4.0. And today we want to take a look into the topic of customized software versus standard software. As I understand it, at ITK, you are providing solutions for smart factories. And one part of it is building software. So you are building or helping companies to build customized software to solve their challenges in the factory. For example, myself, we are building a standardized software solution for manufacturing companies as well. And we want to discuss that. And I'm very much looking forward to it. Where are the pros and cons for the different software categories? So my first question is, in your experience, when should manufacturing companies go with customized software solutions? And when are they better, for example, compared to standard software solutions?
That's the great question, isn't it? For the companies, you need to decide. I think this depends on the specific requirements and the capabilities of a company. For example, if the requirements can be solved by a standard software, I think that's a fit. Yeah, then the companies should use the standard software, because I think if something is made for a specific use case, it often does it good, and this would be a fit for me. However, there are some challenges where a standard software is not suitable for the company. And in that case, you must consider different aspects, like, is there a standard solution which maybe solves 80% of the requirements and you can do some customizations to it, writing a plugin or solving the challenge outside the standard software, but stay mostly compliant and with the standard software? Or if there really is no standard solutions and you need to solve it, then you need a custom solution. And then it depends, can the company do it by itself or do they need help from some external companies?
And do you see specific scenarios where manufacturing companies really need that 100% for this specific use case? For example, we definitely will need to customize something.
Yes, there are companies who say, yes, we need this fully customized solutions, but it's hard to find a common sense where I can say, okay, that's the companies who need it. As I said, it depends on the requirements of the company. If they have a development team who can support the specific software, or if they have some special kind of machinery in the factory which is not supported by open standards, then it's very unlikely that there is standard software which supports it.
You mentioned that there might be a standard software and then you need to put customization on top. At ITK, do you have a specific philosophy behind it? For example, allow to work with standard systems, but then you customize them at a certain point? Or do you say, for example, we are building everything from the ground up and of course we are customizing everything? Is there a mindset change probably going on in the last years?
I can talk for the industry part, not automotive, health, or rail. And in the industry part, we heavily use technologies from cloud message broker systems. Nobody ever is going to implement messaging systems for one specific use case. That would be an over-engineering. So we use known softwares from the cloud technologies a lot, like databases, message broker, dashboarding tools, and so on. And we integrate them to one fitting solution.
In our preparation call, we talked about cloud already, and you mentioned the importance of architectural questions. Why is it that important from your perspective to think about and elaborate on the architecture in general of the whole system landscape?
I think the architecture of the solution is very important because it forms the foundation, not only of the software itself, but also with how you develop it and how you maintain it. When starting a software project without a clear architecture, the risk increases to build structures around and above other structures which might not fit the requirements. And you build balconies, one piece of code to another, which doesn't fit really, but you do it because you need to solve it. And to not go into that risk, you need a clear plan how you want to develop your software. And this is called the software architecture. We try to consider different system requirements in our architecture. What does the software need to achieve and how efficient does it need to be done? And in this software architecture, we consider the user requirements. We need to know who wants to interact with the software. Does it need to be specifically user-friendly, or is it some kind of microservice which runs without user interfering with it? We need to consider security in the architecture. Who is authorized to use it and how do you ensure that authorized users can access it and so on. We need to consider performance and maintainability aspects already in the architecture. For us at ITK, we do not want to maintain software because we don't have this 24/7 days support for our solution. So we always want our customer to be able to maintain it and to work with it, because this, I think, will increase the customer satisfaction for this product, because nobody wants to have very cost-intensive support contracts and so on.
That's super interesting. We talked about that already in the preparation call, because
Right.
one of the disadvantages of customized software, which I oftentimes hear, is the agency is putting some software in your architecture, and as soon as you have a problem and you want to modify it, you have to call them and, of course, pay them again to do some probably very lightweight modifications, but it's super expensive. And you then said, no, this is not your philosophy. You are empowering the customers to maintain and change the software which you implemented, right? I consider that as a mindset change at software agencies as well. Is that possible because you have new technologies which you can use to empower your clients, or is it just a mindset change? So do you need technology for it or not?
In general, the mindset is more important than the tooling, but there are lots of tools which help integrating the customer to our projects. Starts with the common sense in video meetings with Teams, for example, or ticketing systems, Jira, and so on, which allow a good collaboration in this mixed projects. I think it's also possible without it if you have the mindset. If you want to have this knowledge shift, you don't see writing code as your primary goal, but you see it also as your goal to enable others to understand what you're doing, how you're doing it, and enable them to develop it and maintain it by themselves.
Okay, so now let's get a little bit more hands-on, and we will try to understand how a project on your side usually works, what the specific stages are. We live project implementation plan with you, and you will explain us how you usually go through the different phases. So let's assume I'm a manufacturing company and I ask you to help me to digitalize my factory and implement new solutions. How's that working out together with you?
That's a great question, Benjamin. Normally, we start with a workshop with our customer because we really need to understand what is tackling the customer, what's the problem. And in this one success story I brought for this interview, it was the development of a data streaming platform. The customer had a pain that he was not able to process data which was generated from his production machines in a fast and scalable manner. And in the first phase, we needed to understand what kind of data is it, what processes are it, what are the time constraints, and of course, lots of technical stuff like interfaces and capabilities for running software on customer side.
So in the first phase, then you start to understand the problem.
Right.
One thing which is probably here and there forgotten about, and you just think about, I need some digital solution, let's start. But before you start to implement something, you need to understand the problem very well.
Exactly. And we also look a little bit left and right, of the problem. Sometimes the customer says, my problem is the database. And if you start asking silly questions like, what do you need it for? And what do you store there? You find another solution which might even fit better. This is what we do in the first step. And if we identify a possible solution, we often do a proof of concept. Because why do we do it? It's for minimizing the risk on our side and on the customer side, because we often work with some new elements of technology because we believe they can solve the problem better. But you also have a little bit of uncertainty. Will it really work? How good will it work? Will the customer like it? So we do a proof of concept, which in this case was done in 1 month, so 4 weeks for proof of concept, where we took the key components of our architecture. In this case, it was Apache Flink with a dashboarding tool. It was for the proof of concept Apache Superset. We put it together and we fed customer data. And we just showed, okay, with these building blocks of technology, it is generally possible to solve the problem.
A very important step. So the first step where you bring everything together and then you bring it to life. So the technology is working, the customer data is there, and you see this concept can work out in real life.
Exactly. If we agree on this basis or on this solution, we start in our development phase. This means we set up our development team on our side. Often the customer says, this is our development team on our side. And then we set up the infrastructure and start working together.
At this stage, is it just your team working on the technology, on the code, or do you try to share some knowledge already with the customer, or you probably have customer developers as well, and then they join forces?
In that case, we worked jointly on this project. Like we had a Scrum Master on our side, and it was an agile project. So we had 3-week sprints, and it always changed a little bit, but the Scrum team was about 8 or 9 developers. So it was 4 or 5 on our side and 4 or 5 on the customer side.
And then what is the next step?
During the development, there needs to be some kind of knowledge shifting. The first months, our engineers were writing code and explaining it to our customer. The best thing in my eyes were hands-on sessions, where you try to make a demonstration and try to solve the next problem. And what we did is we built another element for showing the solution to the customer. It was an MVP, minimum viable product, which was more like the proof of concept because it was deployed to production systems and it run with production data in parallel. I don't want to go too much into the detail, but then you take the features step by step and try to implement them, always feeding the system with production data. And sometimes you get surprised what the system does because you haven't seen one special case in the data. And then, in agile manner, you need to fix it.
Is it some kind of soft launch of that solution that you say, okay, you have your proof of concept, then a step afterwards, the MVP, this is the first version, which is really working like you expected, and then step by step you bring it in production? Or is it more like a waterfall project that you say, okay, 12 months later, then we will push the button and it will go to production?
Yeah, of course, we have this time constraint when you want it to run, but it was an incremental approach. As you said, you run it in parallel. You only use machine data from 5 machines. And if that works, then you take the next 5 machines and the next data type and put it into the solution. And it always runs in parallel. We had, in this case, a message broking system in the architecture. So it was no problem to feed different versions of the software with the same data.
What is happening then?
At some point, you are confident with your solution and you say, okay, it's ready to run. And then you start rolling it out for the production system. And in parallel, we develop a CI/CD pipeline, continuous integration, continuous deployment pipeline, which allows to automatically test changes made to the source code and to automatically deploy the code to the production system. And this is a concept which helps very much in developing and deploying modern software solutions, especially if you don't work on one big version, which you say needs to go live at a certain date. You rather do small changes, this incremental change, and you deploy them immediately and have these smaller releases in software.
Yeah, this is a practice which is super much state of the art when you think of software developing. And I found it very astonishing when you said that you are building this customized solution with a CI/CD layer on top. But as I understand your whole philosophy, and it helps then later on to maintain the solution much more easily.
Exactly. And if you want to train someone and you have this staging environment, it's easier to train someone because he can do some errors, some failures, and it will not break the production system. You're prepared for it.
Okay. Now you have your new project running. It was successful. And now for every listener of the podcast, it is super interesting to get your do's and don'ts. So probably you had some learnings. And when I think about projects, of course, are some learnings. What would you say? So what would you do again? And probably what would you not recommend for doing again with customized software solution implementation projects, if we take it that broad?
First of all, on the do's side, I think it's important to be honest with your developers, to be honest with the customer, to speak out if you see any risks and problems, because this is what we expect from our customer. And this is what we want to give him back when we develop such a solution. This is maybe the one and only thing I would say that's the most important.
Be transparent, be honest, something which is hard to achieve because oftentimes you probably have a problem, but you do not want to speak about it because you think you can solve it for yourself. But probably it would be much faster if you share the problem with your customer, then you can solve it together.
And on the don'ts side, it's hard to sum it up, but what you shouldn't do in such a project is do something with data which you haven't seen. If there is documentation from a machine interface, and you shouldn't develop and never have seen the data coming from the machine or the real data from the machine, because this can be surprisingly different. Especially in the production environment, there is code running on the PLCs, which might be different from machine to machine, so it should be the same. Although the documentation says all the machines are the same, actually they aren't. So don't take it for granted what's in the documentation.
Sounds like a very good advice, and I can connect to that because sometimes you tend to probably just solve the thing on paper and just work with the documentation. And as soon as you go to the factory and test some things, the reality looks different. And I think your advice points into the direction of working in small incremental POCs like you described at the beginning. Having an idea, testing it, and then iterating. Awesome. Thank you, Manuel, for that look into your real-life implementation and sharing your learnings with it. We are coming, unfortunately, already to the end of the episode. And in my last question, I would like to get a glimpse of an idea of how you look into the future. So what is your vision for the factory of the future? How will it look like 10 years from now?
I'm not sure if I can look at 10 years in the future, but I see two big trends currently. The one is artificial intelligence, as we have seen it since almost 1 year from ChatGPT and OpenAI and all the other large language models, which will have a great impact and already have a great impact on how we decide, how we work from developer side. And this will have a huge impact on the smart factory. The second big trend I see is in robotics. Tesla Optimus Bot, or there are different other robots which come with a very good software to program their tasks. I think this artificial intelligence will be connected to this robot's technology, and this will massively change how factories will be operated and run. So if I look 10 years in the future from now, I think there will be much more automated manufacturing processes, and there will be less people doing actual programming of these tasks because it will be much easier to do so.
Yeah.
I think you already see it with the cobots, these, let's say, slow-running robots which do not need a security fence. They already can be programmed by someone who doesn't know how to code. And I guess these two technologies will change it.
Thank you, Manuel, for that vision and for the whole interview. I learned a lot. It was super exciting. Thanks for being on the show.
Thank you, Benjamin, for the opportunity to be on the show.
Thank you for listening, and we hope you found this episode valuable. If you enjoyed the show, please leave us a 5-star review. You can find more information and resources at operationsone.com. This episode is brought to you by Operations One. Operations One is the leading platform to bring operations to a new level of excellence. By supporting frontline operations from planning to execution to analytics, companies benefit from an empowered workforce, increased operational excellence, and future-proof operations. Visit operationsone.com for more information.